Hello there, ladies and gentlemen. Today we're going to talk about what's called constructing functions. And really this is something that we've done before, but we're going to kind of get more into the analytical talk and the stuff that's going on behind what we're kind of building while we do this, okay? So basically our goal is that we should be able to create a function and make it an equation. We should be able to look at it as a table and be able to look at it as a graph and kind of notice how each of those representations talks about the same sort of information, all right? So here's kind of our example we're going to go through. So Dylan's planning to have his birthday party at a skating rink. The rink charges a party fee plus an additional charge for each guest. We're going to use this table to answer the following questions. So here's a table, and what we're going to do is basically we're going to walk through how we build a function from this table. We kind of actually already know a lot about how to do this. So the first part is to find the rate of change. Another word for rate of change is slope. Okay, basically they're saying, hey, find the slope of a line that's designed by this table. Okay, so we're going to go ahead and we're going to say, all right, let's pick 2 points. I got a point here, I got a point here. Let's label them. So we have x1, y1, and x2, y2. And let's use our slope formula to figure out the slope for the equation that would represent this. So 56 minus 53 over 2 minus 1, which is going to give us 3 over 1, aka 3. That's going to be our m value, right? So m is going to equal 3 and y equals mx plus b. That is our slope. Okay, if you think about in the problem here, slope and rate of change are the same thing. How is something changing as we go along? You can see the charges per guest. That is what the slope is talking about. How is it changing as we go? Let's come back to that in a moment when we write the full function. So now it says, hey, write a function that represents this situation. So let's go ahead and let's take this. We're going to have y equals 3x plus b. Let's go ahead and let's plug in a value. So let's pick one. I'm going to pick 153. Let's put that in. So 53 equals 3 times 1 plus b, and solve for b. All right, so 53 equals 3 times 1 is 3, so 3 plus b. And then I'm going to go ahead and subtract 3 from both sides, and I'm going to get that 50 equals b. So my equation is going to be y equals 3x plus 50. Now, the problem with writing my equation like this is that it's not very descriptive. We just have our generic x and y in there. And what if I want to be more descriptive about what I'm talking about in terms of this scenario? Well, luckily for me, my table actually kind of tells me, hey, instead of using x, why don't you use g for guest? And you know what? Instead of using y, why don't you use c for cost? And let's write this in function notation so that people know this is a function. So c of g, write our function notation, c of g, is equal to 3g plus 50. There's a good function to represent this scenario, okay? That slope, that is, as our guest change, right, here's our variable for guest. As that changes, we're charging $3 more every time we get an additional guest. So the cost for each guest is $3. Your y-intercept, that b value we just found, is 50. That's sort of like your upfront cost, right? What does it cost up front, okay? So let's go ahead and let's look here. Graph the ordered pairs, extend the line of the graph until it crosses the y-axis. So we're going to have to use a little bit of a scale here to do this. One thing that you're allowed to do, so we're going to do this as 1, 2, 3, 4, 5, and 6. When you're going to graph up here, we actually, instead of going by like tens or something to get up to 60 and 70 and have everything be scrunched in and not be able to see it, we can actually skip some numbers as long as we show a little squiggle at the bottom. Okay, so we're going to start with a squiggle, and then we're going to pick a number to start off on. I'm going to start with 50, and then I'm going to go by 3. So we're going to have 53, 56, 59, 62, 65, 68, and 71. Okay, so I'm going to go by 3s, and that's going to kind of be the scale I go by. Again, kind of skipping up to 50 right away. And so we have 153, so that point's going to be here. The next one we have is 256. That's going to be here. We have 359. That's going to be here. The next one we have is 462. That's going to be here. 565. That's going to go here. And then 668. That's going to go here. We kind of extend that out. Sorry, my line's not perfectly straight, but we can see we're hitting 50 as our y-intercept, which makes sense. Look at the equation we came up with. The y-intercept was 50. The graph touches at 50. It then says, hey, use the function to find the amount the skating rink charges for the party fee. So that would be, hey, when you have no guest, what do they charge us up front? What's the cost of that party fee? So I'm going to plug 0 into my function in order to figure that out. So 3 times 0 plus 50. Let's see what that gives me. Well, 3 times 0 is 0, plus 50 is going to be 50. So when I have no guests come, the cost is going to be $50. Okay? And then how are the graph and the function and the equation related when finding the party fee? That's really the big thing we want to make sure that we make the connection here. A lot of this stuff we just did is stuff that we know how to do. We know how to graph a line. We found slope before. We found y-intercepts before. We've done all this. Why is this a different lesson here? Well, it's the connection between these things. This table is talking about the same thing that this equation is talking about, which is talking about the same thing this graph is talking about, okay? The table shows me, as I go up on the table, I'm going up by $3. That was the slope of my equation, which is how much am I getting charged per guest I bring to this party. The $50 up front, I can see that that's my y-intercept, right? And that's the y-intercept of the equation. That also was the upfront cost that they're charging me in the skating rink. And again, we've talked about before that slope is your rate of change. Your y-intercept is upfront initial amount or upfront cost, okay? And I can see that again, even if I think of this number of guests, if I take this down to 0 on my table, it would make sense my next value would be 50. So all three of these things are talking about the same thing. My slope is my rate of change. I can see it in my graph. My y-intercept, that's the upfront cost. We even found it to be that. When we plugged in 0, we got 50. That's where it crosses the y-axis. All those things are all connected. So finding that party fee, the y-intercept, that's my initial amount. That's my upfront cost. My slope, that was my rate of change. That was how it's changing over time. When we're building functions from word problems or from tables and making them into equations or making them into graphs, we want to make sure we keep that straight. Slope is how is it changing. Y-intercept, what's that cost up front? What's that initial amount? Can you take a table and turn it into an equation? We've done it before. Just, now we're doing it more. Here's the words. Here's the equation. Here's the table. Here's the equation. Here's the graph. All talking about the same thing. Thank you all for watching.